Starting recording.
Okay, I think, yeah, Santi also joined. Okay, guys, welcome to the Aurena Technical Stream. This is day one. So purpose is to, gather information and knowledge about Aurena because due to the limited knowledge and experience in Aurena within the team, and compared to the incoming Aurena issues, and of course, considering the future products of IFS as well, we thought of conducting a session to share the knowledge of Aurena. And having said that, our objective is to bring the entire team up to speed with Aurena, with the technical information. And to do that, this session will cover the basics of Aurena framework, technologies, and its practices. And also, this is not a regular Aurena training session, which is usually being arranged by the training department that is conducted for a few days. Our focus is to quickly grab the concepts and its practices, especially targeting GST investigation, as in how can we use Aurena theoretical knowledge to actually investigation Aurena issue. And I think hope everyone will benefit from this. If you have any questions, please raise them then and there. Please clarify all your issues right here. And if you have to start, as per today's agenda, we will start with the Aurena concepts and theories, which will be covered by Safras. And then we will move on to an Aurena project, which will be covered by Safras. It will be covered by Samira. And that will demonstrate the theories, which will be discussed in the first stage, and also a practical scenario, how to implement a project, and include the customization. Anyone have any questions up to now? Any clarifications regarding the session? If not, Safras, over to you. Thank you.
Yes, thank you, Nalaka. So, yeah, first I'll start sharing my screen. Let me know when you can see it. Can you all see the screen?
Yes, sir.
So, yeah. Okay. So I'll start the presentation. So what I'll do is, if you have been part of the Aurena trainings, initially, there is a section to cover the basic technologies that are used by Aurena. And then you talk about the concepts and the architecture in Aurena. So what I will do is I will quickly refresh those two presentations. So as Nalaka stated, so this is not a substitute for the academic training conducted by IFS Academy Technical Trainers. So the objective here is for the people who have already been with Aurena trainings, just to refresh your knowledge on it. If you have not worked with many Aurena tasks or anything like, so it'll be a refresher for you all, so that after the training, you can right away start working with it. And for the members who have not still been part of the Aurena trainings, this will give you some sort of a basic idea about Aurena. So maybe you can start attempting some tasks as well, simple tasks. So I think you will get the basic foundation to understand the concepts and also, basic investigations. But if you feel that it's a bit hard to understand the stuff and all, that's perfectly fine. So when you join the training, then we'll get into the details. So first, as I said, I will start with the basic concepts or basic technologies that are used in the IFS Aurena framework or the Aurena application. So these technologies are not specific to IFS. These are common technologies that is used by the industry. So I'll just walk through these technologies, but I will not go into the detail level, but just give you the basic idea. So first we'll look at what is HTTP, right? So it is a communication protocol, or it's a protocol used for communication over the internet, right? So with an HTTP communication, you have a client, and then you have a server. So then you communicate through HTTP messages. It could either be a HTTP request, or it will be an HTTP response, right? So don't confuse the HTTP with TCP. So if you are familiar with the open standards, TCP is a transmission control protocol that works with layer 4, whereas HTTP is like it's not a transmission protocol, but like it gives you the standards for interpreting the communicated messages from the client or server, and it's a layer 7 protocol, right? But you don't need to know the details as such. So HTTP, you have the client, as well as client will be a typically web browser. Then if you want to access internet or URL, then you type the URL, and then it'll go over the net to the server where it is hosted, and bring back you the page, right? So with HTTP, I mean, we have two types of protocols. If you've known that we have the pull protocols, then you have the push protocols as well. So with HTTP, it's a pull protocol. So you have to initiate with a request for which you would get a response. But there are some, push protocols like sockets, web sockets, if you have worked with, where you don't need to, directly send a or initiate a request. You the server is able to push you the content. So those are push protocols. So with HTTP, the other thing that is of advantage is it's a stateless protocol. So what is a stateless protocol? So the request, subsequent requests, I mean, it doesn't preserve the states, or it doesn't know the information about the previous request. So the state is not maintained or preserved between the requests. So, what is the idea? Like, I mean, what are the benefits of being a stateless protocol? That is, I mean, that gives you the ability to scale your application, and also work with, layering and stuff like that, which we will talk about later. So, why it is so is like with each request that you send to the server, it has the information on how you can uniquely identify a client, right? So the server doesn't have to keep track of the clients that it is working with, right? So you can quickly, or you can identify with each request what the client is and who is the client that has sent this information. So you can quickly scale to any number of clients, since you don't maintain any information, and also all these requests could come through any number of layers, right? So that is a stateless protocol. So with the HTTP protocol, we have some defined request methods. So these methods are used in Aurena as well, which I'll show you later. Typical methods are get method. Get method is used when you want to retrieve a particular web resource from the server. So it could be, say, if I talk in our terms, like it could be a query to retrieve the results, right? So that is a get operation. Then you have the post operation. Post operation is used to create a new instance of a record. So it will be something similar to creating a new record, right? And then you have the put operation that is used to replace the existing instance of a record. So it's used to recreate the existing record. So there is a patch operation as well. So the difference between put and patch is like both it is used to modify an existing record, but with the put you send the whole record and you replace what it is there in the server. But with patch, you you send specific attributes related to that particular record. So you only send the modified data sort of. And then you have the delete operation, which is used to remove the data, right? So these are the basic HTTP request methods, which we will also work with in our REST architecture. Yeah. So another important thing is to identify, what it is used to uniquely identify a particular resource over the web. So this is the typical web address that we have, right? So it has 4 parts. You have the protocol, then you have the host. The protocol could be HTTP or it could be other protocols as well. The host is the server's IP address or the domain name for that matter. And then you have a port. Typically HTTP it's port 80, but you can configure the ports as well. And then you have the path and the file name using which you can navigate and identify a specific resource in that particular server. And on top of these, you can also pass some parameters, action parameters that can be used for different reasons. Like say, for example, query parameters when you want to get some records, or filter parameters, or when you want to post something, if you want to pass some data and so on. Then there is an option. You must have seen like after the URL, then you add a question mark, after which you send these query parameters, which can be interpreted in different ways by our applications, as long as you have the implementation or the support for it, right? And there is also one thing that you need to be aware, the difference between a URL and a URI, right? URI is like in a specific resource, if you want to identify a particular section. Say for example, you must have worked with web pages where after the URL you enter a hash sign, and then you specify the particular section that you want to access. So the section you call the particular section you call the URN, that is the uniform resource name. And if you take the URI, it's the full path. That is a URI, it includes the URL plus the URN, right? But with REST, we will work with URIs to identify the particular resource. It could either have a section or it might not as well, right? So there could be some cases where the URL and the URI are the same, but there could be other cases where they are not same, right? So let's see how the information flows between the client browser in our case. So you issue an internet address. The browser would send a request message to the server. And if you take a look at the request message, it will contain the HTTP method. In the request header, it will contain the HTTP method that was used with that particular message. And then it will have the URL and the HTTP version, and then the host and the port name, right? And it will also have an optional body content if you want to transmit information in addition to the header. And then with the server, it will map the URL to find the particular program under a particular directory or perform some sort of an operation, and then it will return you a response, right? So you have different response categories. Say for example, you have these message numbers. If it starts with hundreds, then it says it's an information message. Then like 200, it's a okay message or a successful message. And then you have a response 300, which is some sort of a redirect to another message. And then you have the message 400, and then message 500, that is like 400 if you can't find a resource uh, in the server, and then 5 it could be a a client error sort of. Yeah, it's to denote server error as well as a client error. So those are the typical response numbers. So a response could also have the HTTP header, which will contain the HTTP version and the response, whether it's okay or not, and then it can contain an optional body. So you return that browser, which will format the response for you and display it in a nice way for you to visualize the content. So this is the typical flow of an information. So I'm not going to go into the details, but here you have a typical structure of an HTTP request and a response message. So you have the message header, and then you have a blank line, and you can have an optional message body, right? So in the message body only you transmit the data. Say for example, if you want to perform a new operation or a post operation, you have to send some data with the message. So that data we call it the payload sort of. So that will be part of the message body, right? So this is a a typical HTTP request header. So if you have the message post operation or the HTTP method and then the version, and these are some other parameters. So I won't go into details, but just to give you an idea. So this is the host or the client. Client or sorry, this is the server and this is the client. User agent is the client. So you can identify, I said like it's a status protocol and so on. So you have to have some way to identify the client. So you have information about the user agent who is sending this information, and then you have these accept parameters. So with this one, say if you take the first one, it is the MIME type, right? So the format of the content that will be passed with the particular HTTP message. It could be so HTML, or it could be a video, it could be XML, or there are different. So it says this particular client will only accept messages of this particular type. So the server knows when you want to send that information, it has to be one of these types. And then information about the accepting language, and then the encoding that it accepts, and then it has some general headers. So for example, information about the connection, and then information that it is sending, here it sends the connect or content type multi-part form data. So it is the information that you fill in a form. So this one, it says what you would accept from the server. This says what you are sending to the server, and then you have the information about the size of the content and so on, right? So that is an HTTP request. So this is some example on that. So similarly, you have the same structure with the HTTP response as well. You have the response number, and then some specific response headers, information about the connection and the content type that you are sending, uh, and then when it was modified and the server information and all that, it is there, right? This is a response header, and you can have an optional body as well, right? So if you take this particular example, the body, it has this HTML body. So it's the my home page that is there. So these are MIME types. That is the content type that I talked about. It is the format of the content that is being transmitted as part of the HTTP request or response body, right? And to identify it, we have a type as well as a subtype. So the type is the main type, that is it's a text, whether it's a plain text or an HTML text. So if it's an image, what sort of an image? If it's the video, what is the format? And then you have the data communication information. Like for example, in Aurena, we are using application JSON. So the data is passed as a JSON objects. So we will come back to that. So you have information about this. So these are some examples. And then you have one other type called multi-part form data type. This is if you want to send information of a completed form. Like for example, you have a form which users need to fill in. So that will contain a lot of information. So if you want to contain or send that information, we use this type, multi-part form data. So different parts in this format are form data type is separated by this double dash. So all this, the HTTP request or a response, if you work with an, say Chrome browser, for example, you have the network console using which you can inspect the body, how it looks like, and you can, see these different types. I'll show you an example later as well to see how this works. Okay, so then we have the HTTP protocol. Information about HTTP, what HTTP protocol, and what a URL is. I mean, to identify a specific resource in the server. And then we talked about the HTTP request response message content, or the headers and the body, what is included in each. And then we talked about the MIME type, the format of the content that is being passed with the HTTP message bodies. Now, like if you go into the detail that we'll talk about the data exchange formats. So we have the JSON and XML, and there are the formats as well. But I mean, these are the data that is passed as part of HTTP request response bodies, right? So you have worked with XML already, so it's extensible markup language, and it has a nested structure where you have a start and ending tag. Likewise, you have the JavaScript object notation. So it is another way to describe the data that you want to send. So here, like, have a nested structure here as well, and it supports arrays sort of, or collections. So if you take the bookstore, it has a book array, and this is sort of the first book array element, and this is the second book array element. It is a name value pair, right? So if you compare these two, XML object and the JSON object, you can see that JSON object is less verbose, right? So that means it has less number of words. So the advantage that we have with this is, like, I mean, it is much more friendlier on the network bandwidth because of the size of the content. The same data can be passed with JSON object with a small size, right? So it is much more friendly on the network. So these are some rules, JSON, how to interpret the syntax rules. So I won't go into details, but the basic idea is it has name value pairs, and it has a nested structure as well, and it supports different data types: string, number, or an object, an array, a boolean, or null data type. uh, yeah. So if you compare JSON object and XML object, there are some similarities as well as differences. It's both human readable, and it has very simple syntax. Both are hierarchical, and it's language independent and can be used by Ajax cores. It is supported by many APIs and program languages. So if you take a look at the differences, syntax are different. JSON, as I told you, like, it's less verbose, so less number of words, and it can also be passed by JavaScript's eval method in the client. So it includes arrays. So the JSON object, it can't use JavaScript reserved words as well. And the XML, you can validate against a schema, whereas JSON you can't. Right. So those are basic differences. And then we have another data exchange format called the Atom Publication Protocol. So it started with Atom. It's an extension to the XML based file formats. Initially, it didn't have support for HTTP methods and so on. So later, it was extended as Atom Publishing Protocol with support to HTML methods, different HTML methods, and also it has supports to collections and stuff. So this is typically used with feeds, for example. Say if you have worked with blogs and so on, You can subscribe to a particular blog, in which case you will get feeds. And so for that you use this Atom publishing protocol. And also like the other uses with Atom collections is, for example, the service data or service metadata. If you want to take a look at the services that has been exposed by a server, then that information, like if you have worked with web services, you must have known about WSDL files. It's somewhat similar to the XML files, but you can visualize such information with Atom as well. So these are some examples on that. So Atom feed document. So okay, so we'll now move on to the important part when it comes to the Aurena. So it's about RESTful web services. So what is REST? It's the representational state transfer. It's an architectural style, right? So it's not a protocol. It is not an implementation, but it sets out a certain standards that you can follow when you want to implement. So it's a design style or an architectural style. It's used to develop web services. So in this REST architecture, both the data and the functionality are considered as resources, and they are accessed based on URIs, and they are manipulated by using standard HTTP methods that I described before, right? So that is REST. So don't confuse with REST with OData or anything. REST is actually a architectural design style which lets you, gives you some sort of standards. If your web services needs to be a REST API, then it needs to follow certain standards, right? So you can think of it as a virtual state machine sort of. So you have the application. It is envisioned as a collection of resources consisting of multiple states, right? It has a set of resources with each resource has its own state, and these resources can be used by accessing the URI or giving the path, and the state of these resources can be modified by using the HTTP methods like get, delete, or post, push, and all that. Or you can also navigate from one resource to another, right? So that is basically a REST. So you can think of it as a collection of resources having its own states. Say, for example, if we talk about our stuff, like you have a collection of say entities or entity states and so on, like it has its own state, and we can perform certain operation and modify those entity states, so that will change the state. So it is bound by certain constraint, or it has certain characteristics, I could say. Like it is REST is actually, it follows the HTTP, and it has the client service architecture. It is stateless, and it has support for layered as HTTP, so you can easily quickly scale your application. There are some functionality where you can cache as well, and you have a uniform interface to identify a request or resource identification request, and the resources are manipulated using representations. So here we couldn't talk about one thing, like I talked about the state transfer, where I said like it consists of a set of resources which are manipulated using HTTP methods where you change the state. And like to manipulate, you pass the information as representations. These are the JSON objects that you pass, like the message bodies, to access those resources, or like modify the state of those resources. We pass representations. That is why it is noted as representational state transfer. You change the state of resources through representations by passing that data as representations. So the resources are manipulated through representations. it is self-descriptive messages, and it is a hypermedia as the engine of application state. So it is similar to the hypertext protocol that you have, that is used to transfer from one resource to the other, or navigate from one state to the other. Likewise, we call this hypermedia engine as well, to change the states of the application. So these are some examples of REST and HTTP methods. So I won't go into the details again. You have, if you take the URLs or the server, you could have different resources. It could be a collection, or it could be a specific instance of a particular collection. And then you have different HTTP methods, and how it works for a particular collection, and how it works for a specific item in the collection. So if you perform the get operation on a collection, it will return you the whole collection. But if you want to perform a get operation on a particular record, then it will return you the particular record only. And if you take the put operation, as I said, it's to replace the entire collection. That is, it'll pass on the whole record or whole set, and then it will replace it. And if you send it on a particular item, particular instance of a collection, then it will only replace that particular item. And with patch, you don't generally use it with collections, because the difference between put and patch is, put you send the whole instance or whole record, but with patch you only send the modified attribute for a particular record, so that you can use it. So the patch operation, you can use it with a particular item. And then when it comes to post, it'll create a new entry. If you perform a post operation, it'll perform a new entry on the collection. So on a particular item, you can't perform a new on an existing item, so it's not used there. But the delete method is like, if you want to delete the entire collection, or you can delete a specific member in the collection as well, right? Mm, do you have any questions on this, what I've talked about so far, the basic theories? All are okay? Okay, so I'll move on to the open data protocol. So what is open data protocol? I talked about RESTful web services, and I said that it is an architectural style for developing web services. And if you take the OData, or open data protocol, it's an application protocol, or it's an implementation of the RESTful web services, right? So the RESTful web services it's an architectural side, and open data protocol, it's an implementation of the RESTful web services, right? So why is it important to have such a protocol? Say for example, you communicate using REST, and then different companies have their own implementations. You represent data in the database, and you have certain operations which you can perform on those entities or data that is there in the database. And we have our own implementations on how we can modify or change the state of those entities in the database, and so on. And then IFS has its own way of implementation, and then say for example Microsoft, it has its own way of implementation. Then why do we need open data protocol? If we want to interoperate between applications, we need to have a certain standard to expose the data that we have, expose the data and the services that we have in our systems, right? So that is where open data protocol comes in. So that is like for interoperable applications, you have a certain standards in which you can expose your implementation or expose your data. The implementation could be anything. You can write your own implementation, but if you expose it based on the OData protocol, then any OData compliant client can use it and access those services, right? So this was initiated by Microsoft, and then later it became part of Oasis organization, and now it's being maintained by them. So it's an application level protocol which allows the creation and consumption of interoperable RESTful APIs, right? So if you take the open data protocol, it has HTTP, it's built on TCP, and then you have the open data protocol which works with HTTP, and the data representations are AtomPub, JSON, and XML. So open data protocol works with HTTP using data representations, JSON, XML, and AtomPub, etc. If you take an OData technology, how can you represent the data and so on? We have 4 components. One is the data model, so it gives you a generic way on how the data should be organized and described. And then you have the service model, it gives you some guidelines on how it should be exposed, or on how it should be exposed. And then you have the data, and then the service model on how it is exposed. And then you should have client libraries using which you can access these service model that are there, right? So you need to have certain client implementation to understand the OData that is that is implemented in the service model. And then you have the OData protocol, so that is the basic communication protocol between the client and the service, right? So it has 4 components: the data, how you have to organize the data, and then how you have to expose the data, so that is on the server side. And then you have some client side implementations to interpret the OData stuff that is sent to client and so on. And the protocol is actually used for communication between the client and the server, and how to expose the data as part of OData, right? So if you take the data model, it's called entity data model. And you have entities, relationships, entity sets, actions, and functions. Entity type is it's the basic structure. Say for example, if you have the customer entity, so customer entity type, it contains the structure and the key and so on. And then if you take the entity, it is an instance of a particular entity type, right? And then if you talk about entity sets, it's a collection of entities, right? So you have the database structure, entity type, say a table, and then one instance of it is the entity, and the collection of entities, or the set of rows, it's called the entity sets. And then you have certain relationships. Relationships are, for example, we have association, aggregation, all those relationship types that we have. So it describes them as well. And then you have actions and functions. What are actions and functions? Actions are commands or operations that change the state of the database. So for example, you can think of it as procedures. For example, you perform some post operation or implementation of the post operations. And then you have functions. It's similar to get methods and so on. It doesn't change the database state, sort of, right? So you have enumeration types as well. And entity sets, it's a collection of entities. There is a entity key which can be used to uniquely identify a entity in the entity set. And then you have operations that allow you to perform custom logic on parts of the data model. It could either be functions or it could be actions. And these actions and function can either be bound to a particular type, or it could be unbounded. In that case, it becomes like static methods. So an OData resource is anything in the model that can be addressed. It could be an entity set, entity, or an operation, or it could be a property. So that is data model. Then you have the service model. That is how you expose the particular data model to the clients, right? So you have a service document that gives you it gives you a list of services that are exposed, and then you have a metadata document, which is somewhat of a a detailed implementation of the services, like the parameters and data types and so on. The service document lists entity sets functions that can be retrieved. The metadata document describes the type sets functions and actions understood by the OData service. So how OData works, you have a customer entity, and then you have a customer's entity set, which is a collection of the entities. And then you access it, you specify the service route for the particular URL, and then it will give you the service document, which will list down the services that are there. Or as you can access the metadata, service metadata, for the little more detail into the services or the entities and entity stuff, like what are the data types and all those details that is there in the metadata document. And then you can directly access the entity sets as well, like you have to go to the service route, and then you have to specify the entity set using which you can retrieve the entities or the records that are part of the entity set, or you can access a particular record as well, right? So there are certain standards on how you can use these calls. So I think like it's described in the next section, so I'll skip this one. So how it works behind the scenes is like you specify the entity set that you want to retrieve. It'll generate an HTTP message, and then it'll send it to the OData service, which will interpret the particular message that was sent, and it'll try to find the implementation, get the record that was requested, and then send it back to the client using the HTTP and using data representation JSON. Right. So here there are some exercises, like you have this Postman app using which you can try out different OData calls. Say this is, for example, there is the OData organization, it has given us one particular service which we can use for testing. So it is called the trip in service. If you have the Postman app, you can try this out. I mean, this is the service route. If you, for example, if you go into the details, like you would see like the different entity sets that are part of this service route. And then like if you specify the metadata, it will give you more details about the implementation of the entity sets and so on. And then there are different ways, like there's a particular entity set, what is the syntax for accessing an entity set, what is the syntax for accessing a particular record in the entity set, like request a particular property attached to an instance of an entity set. So here it says like from the people in entity set, for the person with name Russell White, send me the first name. So it will give you the first name sort of. And then like you can perform certain operations as well using the filter tag. So this will in the database, it will translate into a where clause, where first name equals Vincent, and it will return you this records. And like you have different other keywords, like top equals 2 means like it will give you the first two records of the particular query. And if you say, for example, skip 2, then it will skip the first two records and give you the next set of records, next two records. So these are some syntaxes, like if you want to select certain properties, first name and last name. And then like you have the expand syntax, that is like it's as associations. For example, in our case, if you want to view the LOV or list of values and so on. So you can use this expand keywords. So it will give you the details about the friends or the relationships that is attached to this particular lesson. And then this is how you can access the functions that is attached. So if you talk about Apache Olingo, it's a Java library that implements the Open Data Protocol. Why it is here is like in IFS Arena, we are using this Apache Olingo library to implement our OData, open data provider. So like it's an implementation or a Java implementation of the REST protocol, REST standards. So I'll come to that a little later as well when I talk about IFS Arena specific things. But these are the basics. Do you all have any questions? I think we'll be running out of time, but I'll show you certain operations. See, for example, if I go into this Arena page, say this is the home page. You have the navigator, and then like the page container, and then you have different settings options. If you want to change the theme, and if you want to view the documentation, and if you want to view the debug console, and so on. So like here you have the navigation menu and the home page, and then you have the recent screens that you can look. But say for example, if I go to one particular window, say tax codes or something. So you have a list of tax codes. So I could have opened the, I'll open the network protocol and show you. So I'll open the network console and show you how it works. So you have the network console, and if I go to, so it was already populated, so you don't get it again. But say for example, I perform a new operation on it. So it'll initially fetch the default values associated with this particular entity set. So if you click on it, you can see like it is a get method. You have this response headers, request headers, and so on. So it'll return you the default methods that is part of this. You can view the response like so you have the company 10. So this will return you the default values, or like if you know the prepare insert method that we have, so it'll I mean from the business logic it will call that and give you the results. So if I add something, say for example, I'll add a new record, say then I perform the save operation. So here you see I have created a new instance for this. So it is performing a post operation, right? And what is the data that it is sending with the post operation? If you go to the payload section, you will see like company 10 in all these values that has been sent with the HTTP request, right? Likewise, if I want to say, for example, do an edit operation, say I want to change the tax percentage to something else, say 20, and then if I save, then there is another call that is performed. So here it is. So here you will see it is a patch operation, right? Earlier when you want to create a new record, it performs a post operation. When you modify it, it performs a patch operation. And the data you can see here with the payload that is sent. Likewise, you can remove this particular record as well. Say for example, if I remove it, I say okay. syntax codes. Yeah. See, have the delete operation, right? So likewise, you can see the different HTTP methods used with different operations. So here, like you can see, there is a populate. So it has this get method, so which has returned the responses and so on. So this is just an example on how you can view what are the different methods that are used and HTTP methods, and what are the parameters that are passed with the different methods. So here you have query string parameters where you are sending the information that you want. Likewise, you can monitor or see everything using the network console, right? Any questions on this so far? Am I going too fast? Can you understand? Are you all okay with this? What does silence mean then?
Okay, Safra, it's okay.
Yeah, okay. So those are basic, the technologies that are used with Aurena. But I mean, these stuff you might already know if you have come out of the universities and so on. You must with REST APIs and then the OData protocol, which is an implementation of the REST architecture. And then you might know about HTTP and all that. So, but that was just to give you a brief refresher. Then now let's see how this stuff is implemented in IFS Arena framework, right? So if I go on to the introduction of Arena technologies, so I'll start with this. So it's a state-of-the-art user experience. You already know about the look and feel. I mean, it can be run in different clients. It's a truly responsive client in that sense. Like it is a a web-based client, so you can run it on any device. So it will adjust the layout based on the device that you are accessing from. So you don't have to build different clients. Earlier, like for example, we had a IE client and we had certain limitations. Like for example, it had limitations for the OS and so on. Uh, it was not possible to run, for say for example, on iPads or iOS. You needed to have a Citrix sort of client to from where you have to access. And like you had different mobile apps and so on, so you had to build it for different clients. But with this, it's a web-based client, so you can access it in any client. You don't have to have different implementations, right? So just to give you an overview on the user experience, it's a visually attractive and appealing experience. It's based on HTML5 and can be run on any operating systems. It has a rich user interaction pattern and responsive to device size and so on. The technology architecture is it implements the RESTful architecture based on the OData version 4 protocol, and hence it is easily consumable by IFS application APIs as well as other clients that is outside, right? So when you expose these APIs that you have, the entity sets or the data, earlier we had to develop our own implementation for integrations and so on, where BIS APIs and stuff that we develop using Develop Studio. The old people, you might be familiar with this middleware development. But with these RESTful web services, when we expose this through OData, you don't have to have different integration developments and stuff. So it is easily consumable by other clients as long as they are OData compliant, right? And then we are using a declarative development language called Marble. where not like earlier where we were using C# and all that languages. So this is a declarative development syntax that we have now, which runs on Developer Studio, and it can be recognized by the IFS Arena pages, and we have the framework support for it. So basic architecture. First, talk about the traditional web applications like old web client. You have a client where you initially send a request, and then you get the requested resource, that is the page that you requested for you, and then like you perform certain operation, and then you have to submit the whole page. That is a traditional web application, and from the server it will return back you the whole page again, like the layout. So this is this consumes a lot of bandwidth. But with the Arena web client, we are using the single page application technology. That is, you initially you send a request, and you get the page that you requested for you, and it's run in the browser. And any subsequent operations that you perform on that particular page, we send it through a Ajax call, right? If you have worked with Ajax, what you do is you don't submit the whole page, you only submit the modified parts. Say for example, a page, it will contain different parts or different sections. So when you do modification on a particular section of the form, you don't have to send the whole form again. So what you do is you only send the modified part through an Ajax call and get the response for that call using a JSON object, only the modified data, right? So you don't get the whole page back. So the page will not be refreshed, only the part that was modified will be refreshed sort of. So that is very friendly on the network bandwidth and also on the network performance. So this is the technology that we are using. And these Ajax calls and the responses, it is all implemented based on REST architecture using the OData protocol. Right. So what are the key components? You have the, as before, we have three tiers. We have the database tier, the middle tier, and then the client tier. In this client tier, our agent is a browser agent. So we are limited based on the functionality that is supported by the particular browser, right? So you have the business logic and the data that is stored on the database. And then the browser, it has the IFS web runtime that, and then like in the middleware server you have the IFS OData provider. So the client, IFS web client runtime, which is used to draw the layout of the pages that you are accessing and so on, IFS layouts. So it will communicate to the database through the IFS OData provider. So the initial communication between the IFS web runtime and the IFS OData provider that is there in the middleware server, it is done through HTTP, and from IFS OData provider to the database, it is done through JDBC. So you send a initiate a HTTP request, with the request that you want, with the operation that you want to perform or the resource that you want to action or request, and you send that request to the IFS OData provider, which will translate that particular request it to the database through JDBC. Say for example, if you ask for a set of objects that are there, you send a get method requesting for certain records that is there, and you translate that call, or IFSO data provider would translate that call into a select statement, send it to the database through JDBC and get you back the request, right? So these are the new components that have been introduced with Arena is the IFS OData provider and then the IFS web runtime. So let's see what they are, like what it is built on. So the communication is between the browser and the server is based on REST HTTP calls. you have the IFS web runtime, and then like in the server you have the IFS OData provider, and the IFS web runtime is built on Angular framework, Angular JS framework. So the client or the web pages are designed based on the Angular framework, and then the IFS OData provider, it is built on top of Apache Olingo library, which is a Java implementation of the RESTful web services or RESTful architecture, which gives you the basic functionality for the OData implementation for the APIs, right? So this is the technology stack that we have. In the application server, we have the IFS OData provider, which runs on top of Apache Olingo, and then we have the IFS web runtime in the client, which runs on the web browsers. That is built on Angular framework. But for you, you don't have to worry about these, Java, Apache Olingo technology or Angular JS. Our framework takes care. I mean, when you model using the declarative languages that I talked about, these translations are automatically taken care of by the IFS Arena frameworks, right? So you don't have to know the details of these two technologies. So if you take the IFS web client runtime, it runs on the browser. It uses IFS OData provider as a gateway to access the data and perform operations that is stored in the database on the logical units. It is based on the Angular JS framework, and the communication between IFS web and IFS OData provider is done through REST HTTP, right? So if you take a look at the IFS OData provider, so it has three components. You have the OData protocol that is there at the bottom layer. Then you have the Apache Olingo Java library, which is a Java implementation of the OData protocol. Why we need Apache Olingo is like we are using a Java web application server, so we need a Java application or Java implementation of the OData protocol. That is why we have selected Apache Olingo. And then on top of that, we have our own IFS OData provider, which is, I mean, to have some sort of customizations to the existing Apache Olingo, or it works on top of Apache Olingo where you have your own IFS implementations, right? So if you look at the abstract view, you have the database, and then like in the middle where you have the OData provider and the Apache Olingo, you have different clients. So all the data that is there in the database is exposed through IFS OData provider to the different clients. So the client could be IFS Aurena client, or there could be many other clients. As long as the client is OData compliant, it can consume the service or the data that has been exposed through the OData provider, right? So what happens is like when you initiate a, say from Arena, when you initiate a request, it goes through OData provider, which has a servlet. It'll read the request, and it'll first redirect it to the metadata loading container. So we'll talk about that to load the metadata, and it use the Apache Olingo libraries, and then it translate the request into PLSQL or database statements, SQL statements. So what does Apache Olingo do, and what is IFSO data provider do? So Apache Olingo, it has the basic implementation to pass the request, and it pass requests and into syntax trees, and it is able to validate the metadata, pass HTTP request, and also like generate JSON results. So what does IFSO data provider do? It provides you the metadata for the the services or the data models that resides on the database, and it generates the SQL and PL/SQL implementations for the request. I mean, it translates the call and converts into SQL and PL/SQL statements. It also handles the security, and also it exposes the client metadata endpoint. I'll come to the client metadata endpoint. So this is the IFS OData provider architecture. So with IFS OData provider, how does the database connections work? It connects to database through the already existing IFS middleware server connection pool. And these connections are initiated the first time using the IFS sys database user, as in web clients and say IE client as well, right? We talk to the database using the IFS sys database user. That is why we said all database objects should be granted to IFS sys. So there is no change with that. But each request, initial request, you send a request to login sys.init ODP session. This is a new method that has been implemented. This is used to initialize the FND user who sends the first request, who is the client user. So it takes care of the security aspects using this method. So from the middleware server to the database, you connect, you establish a connection using IFSs, but the client user, the session is initiated using this particular method, which takes care of the security settings for that particular FND user. Say, for example, it will display only the pages that are relevant to the FND user, the projections that he or she has access to, right? So those things are taken care of by this particular method call. And also IFS OData provider has the implementation to support the different database transactions or actions. Say, for example, rollback or commit based on the status. If there was a error, it can roll back, or otherwise it can commit. So this is how the database connections work. So let's look at the data transfer. So the communication between the IFS web, IFS OData provider, and the database. Right. So this is the initial stack that I showed you in the first slide. So you have the data and the business logic that is there in the database. And in the middleware server, you have the IFS OData provider, which is a new component. And then you have the IFS web runtime that runs on the browser. So IFS web, it will communicate to the database through the IFS OData provider. So from IFS web to IFS OData provider, you send an HTTP REST request, and then IFS OData provider will translate that request and connect to database using the JDBC, right? So you have this initial request to perform an HTTP request, which is then translated by IFS OData provider, and it talks to the database. So for example, we'll look at one operation, which is a get operation or a read operation. What happens? You perform an HTTP get. This is a OData call that you send to the IFS OData provider, which will translate the particular OData request into a database SQL statement, right? So you ask to give you the persons where the age is greater than 18. So it translates this request and converts into a SQL statement, and then it sends to database through JDBC and brings you back the results. Let's see how it works when you want to perform a new operation, create operation. It will be a post call. You want to create a new person with name John and age 25. And then like IFS OData provider will translate this request into a PLSQL statement. Like we'll come to this. I mean, each entity set, it has its own wrapper methods to perform the CRUD operations. CRUD operation, I'd say. CRUD is like create, read, update, and delete. So, I mean, each entity set or projection that I'll talk about, it will has its own implementation or wrapper methods to perform these operations. So for example, for an insert operation, it will call the CRUD create method. Then for an patch operation, which is an update, it will call the CRUD update method, or it will translate the request and convert into a CRUD update statement and send it to the database. And the delete, it will translate into a CRUD delete request, which is passed to the database, and you get the results, right? So that is how the architectural overview, or like how the how the Arena framework is organized. Then let's talk about projections, right? So if you take a look at our traditional IE client, you have the server, you have the database where you have the data as well as the IFS business logic through PLSQL APIs. So there is no change to this with the Arena architecture as well. Then you have the client, which has information about the layout as well as some client business logic, right? So we had some logic in the database, and then there was some logic in the client side as well. So what is the problem with this approach? If you want to have multiple clients, then you have to duplicate all these client business logic into all these clients, right? So that is the typical architecture, or the current architecture that we have with the IE client, etc. So we have the logic as well as the layout described in the C# client files. So if you want to have another client, some sort, say mobile client or anything, then you have to write your own client logic or duplicate the business logic there as well. So with this new concept, what we have done is we have separated the client layout as well as the client business logic into two different containers, right? So client logic is separated into the client business logic is separated into projection files, which exposes the database data that is there in the database. So you have the projection files that exposes the database in the database object or the data object into services which are consumable by all data compliant clients. So you just have one implementation of the projection which exposes all these logic and the business logic, the data that is there, that is associated with it, and it can be consumed by multiple clients as long as it is OData compliant, right? So you don't have to have your client logic in every client that is there. So what we do is we expose it as OData services, which can be consumed by any other client as long as it is OData compliant, right? So how does it work? Uh, so you have the IFS business logic where you have the entities, utilities, and all that, the logics associated with it. And then in the projections, we have the entity sets, actions, and functions. So these entities are exposed as entity sets, and the operations that you perform on these entities are exposed as actions and functions through the projection to the application server, which can be these services can be then accessed by other clients and client pages. So that is a basic concept here, right? So how does the details work out? So we have the Arena projection model. It specifies the data sources and operations that will be made available as a well-defined RESTful web services based on the Open Data Protocol. It is modeled using Developer Studio. So it has entity sets, functions, and actions. And then you have the clients as well. I talked about the projections. I earlier told that we have now split the client logic into two, that is the client layout logic and then the client business logic. So the client business logic is now part of IFS projections. So it can be consumed by any client that is outside, and it will expose the data as services to the clients that are outside. So that is the projections. You expose the entities as entity sets, and then you have the operations that you can perform on these entity sets. Those are actions and functions. And this is a projection model file. And then you have the client model. I mean, we have our own client as well, the Aurena client. So for that, we have our client files, which has the declarative, syntax using which we define pages. It has two levels. The top level containers are pages, assistants, and groups. And then you have sub elements to it, which contains groups, lists, selectors, commands, and dialogues. So we have the client model, and then you have the projection model, which will expose the data that is there in the database as OData compliant services, which can be consumed by the client. So this is how the metadata. So what we have is, we don't have a, as I told you earlier, like we don't have a client implementation language sort of. We develop it, or we use the Marble language. It's a declarative language using which you define the structure of the client, and then like based on the client model, you generate the code which will generate you the client CPI package, and that package is deployed into the database, which will store the information about the client page as metadata, right? Similarly, with the projection model, you generate the code and it will generate you the projection SVC file, and when you deploy it in the database, it will contain you the projection metadata as well as the implementation for the actions or the operations, CRUD, custom method wrappers, and so on, like the create, update, delete, or any other action custom implementation that you have. So the projection contains both the metadata, projection metadata, as well as custom or CRUD implementation. All this is stored in the database when you deploy the SVC file, right? So these are some important F1 packages. I won't go into the detail. Model designs is used to manage projections and client metadata. Navigate assist is used to manage client navigation entries. Say if you want to clean up and stuff, all these navigation entries are stored in the database as well. So you can use this navigate assist package to organize the client navigation entries. And then like you have the FND or data provider sys, which will retrieve the projection and client metadata and expose it through the IFS or data provider. So let's go into a bit detail. So you have the IFS business logic and the data that was earlier there as well with the traditional IE client. Now we have, in addition to the data and the business logic that is there, we have some other stuff from the projection and the client. From the client, it generates the client metadata, and from the projection files, it will generate the projection metadata as well as implementations for the CRUD operations, as well as your own custom implementations for the actions that you implement in the projection. All this is stored in the database. And then like what happens when you make a request, initial request for a, say I'll start with the client. So example, you request for a client, the request will come to IFS or data provider, and then it will go to the database and it will fetch you the client metadata, and then client metadata would be returned to the IFS web client runtime through the IFS or data provider, and then the IFS web runtime would translate this client metadata client layout or the client page that you requested for. Likewise, when you request for a projection item or an operation or anything First, it goes to the IFS data provider. If it's the first time, then it will send you a request, send a request to the database to fetch the projection metadata. Because like IFS data provider, you get a request, then it doesn't have the implementation. It has to know about the implementation. So that details about the implementation, that is the implementations that are done through these wrapper methods, are stored in the projection metadata. So when you get a request, say for example, a request or post request to create a new record, then it has to know the implementation. I mean, what is the package that it should call and so on. So that is stored in the projection metadata. So when you get this request for the first time, it will send a request to the database and it will fetch you the projection metadata to the middleware server. And after going through the projection metadata, then it will be able to translate and identify the database implementation that it should call for, or translate the request into the particular database implementation. So that is why you have two components for the projection. For the client, you have just one component that has the client metadata that is interpreted by the IFS web client runtime. But when it comes to the project, it has its operations as well, where that is where you have the implementations or the operations for the database entities that are there. So when you get a request, you need to interpret that request and you need to translate or identify what you need to do next. So what is the implementation that is supporting that? So that information is stored in the projection metadata. So when you get a request for the first time, it will go to the database and it will fetch you the projection metadata, and it will go through this metadata and identify the particular implementation or the wrapper methods that are there in the database, and it will translate you to that particular request. So that is the flow. So how this works, you have the IFS application models, you have the projection file that I talked about, and then you have the client file. And then you have another file type called fragments. Fragments is like, say for example, if you have some common implementations that are common for many clients or many projections, then instead of duplicating in each client the particular code or in each projection, what you do is you create a fragment for that particular service, and that can be used by multiple clients. So you don't have to duplicate the implementation in each client or projection. So that is a fragment file. And then you have the PLSVC file, which is the source file where you need to, I mean, whatever custom implementation that you do, you have to write your own logic for the custom implementation. Say the CRUD operations, you know the logic that is there. It's a new operation that you need to perform and so on. But if it is a custom operation, say you need to perform a state change, or like you have to run some business logic and you have some action button in the client. So when you press that, what is the implementation that it needs to look for, and that implementation is then provided in the .plsvc package, plsvc file, right? And this is translated, or this is read by the code generator, and then it will generate the relevant svc for the projection and the plsvc file, and then for the client it will generate the cpi package, right? So it is then deployed in the database, projection packages, client packages, as well as the model metadata is separately stored. Then like you have the IFS Aurena client. So I talked about the client metadata endpoint. So when you request for a client page the first time, uh, you have this item called, or a component called client metadata endpoint. So when you send that request, it goes initially to the client metadata endpoint, which will then fetch you the client metadata and send it to the client. Likewise, any the OData requests, actions and stuff, it goes to OData provider, which will then fetch you the projection metadata, and then also based on the implementations that is described in the metadata, it will then translate the request into SQL PLSQL calls and access the projection packages and send you the relevant information. So that is the basic flow. So, this is a somewhat detailed view of that. So here, like the thing that you need to understand here is, like, if you take the middleware server, it has three components here. This is like the OData provider component that we have talked about, and this is the page metadata. It is similar. It is the client metadata endpoint, and then you have the UI web application framework. This is the Aurena client framework that is also stored there in the database. So why it is used for? When you send an initial request, when you the Aurena client first time, I mean, you request for a specific page, but before you request for it, when you log in the first time, it has its own view, or it has its own page, home page, where it has the navigation and then, like, different stuff and the settings and all that. So that is part of the Aurena client framework. So that is also stored there in the IFS middleware server. And when you log in to the Aurena client for the first time, then it is retrieved from the database, from the application server, and sent to the client, after which the client will be drawn, right, using the client runtime. So this contains the Aurena client framework, or the home page stuff. So unlike .NET clients or anything which is not installed in clients, so you don't have a local install base. This one, like, you have the code and stuff in the application server. So when you initiate the first time, it fetches that information and draws you the home page for the Aurena, or the basic container for all the Aurena pages. Then you have the page metadata, which fetches the client metadata, and then, like, projection metadata and the CRUD and all that operations. So with the client framework has provided us, the different client components or client blocks, which can be used in the .client files, and then you can build your own page. So you have support for selectors, groups, lists, and all that. So those framework blocks are there, and using that blocks, you can build your own client pages. There are some common pages that are, common containers or common blocks that are used by all the pages. And then there are some, product specific blocks as well. Like, for example, in HR, time registration, time clock, and all that pages, it's specific to HR. So for that also you have the support. So using all these building blocks, you have to design your own client page. So that is basically the concept part. Now let me know if you have questions or concerns. Was it clear? Do you have a basic idea about the Aurena architecture and how the flow works? Are you okay? No questions?
I think it was very detailed, Safras, and it was clear.
Okay. So if you don't have any questions, let's move to the other section. I think I have taken half an hour more. Samira, you can take over.
Thank you, Safras, for the detailed information. Guys, as for the second part, we will move to the quick development and a demonstration. This will overview what are the core segments we can use in Arena development and how we can perform customization. We don't have enough time to finish it today, so it will be continued in the second day. Samira, this is over to you.
Okay, thank you, Safras. Thank you, Nalaga. Thank you, Safras. I will share my screen. Can you all see my screen now?
You can see
Yes.
Samira.
Yes.
Okay, in today's session, I'm going to demonstrate some basic Aurena application developments. The intent of this session is to giving some insight about how the Aurena works and things you should know in order to narrow down an issue. Also, you will get an idea about how the previously described theories are practically used within Aurena. So, in today's session, I'm going to actually look at these topics, the create develop studio project and develop an entity set. And I try to create a simple page development also if time is available. And as a first step, I will going to create a new IFS develop studio project. So I have shared with you. I think you can see that develop studio project right now. Uh, so in here, the first thing we need to check is when you're going to create a new project, you should check what's the latest version you have installed in your IFS Developer Studio. Because this should be a latest date. Otherwise, you should end up with some strange errors. Uh, so in my case, you can see that my studio project is a recent date, so it's fine. So if this is not the latest date or the next latest version, then you can update to a studio project by going into help, and there is an option called check for updates. By using this, you can update your project. So this is about the developer studio project setup, and then I'm going to create a new project. You can go into these options and create new project, and here we create a new IFS R&D core project, and going to next. And here we are going to create a new fresh project, and I will give this project as uh, in some name. Then we can provide here a build home. Here we are providing a build home to avoid from some dependency issues which can be raised from other dependent components which are not used in our workspace or in this current project, but they can be referenced by the existing components on this project. Simply saying, this is used to resolve some items that are not within our project component set. So here I will use my actually this build DOM of TextCMB. And before giving this build DOM, please check you can access to this location, and then you can copy this and paste it here, and then we can use this tick box. Then it takes the related target version and update level of build DOM. Should I will give a short name for this? Then actually here we are involving with the database type of development here, so no need to tick another tick box. Then actually here we need to create a section for project. You can add the existing project of, or otherwise you can create a new project, a new database connection by going to there, and you can simply put the host and seed, username, password, and the schema will be fetched automatically. And you can give anything as a display name, and then you can create a database connection like this. I have already created a connection like this, and I will use it for my project. Then press OK, finish. Then you can see that my project has been created there, and it has components. Currently, there are nothing. And also you can see the database connection here. And if I check the build DOM, then you can see that all the components available in this given location, the given build DOM, are available in my project right now. So this is how we can create a Developer Studio project. Then actually in support, we do not involve with creating new components or creating new entities. Always we use already existing components, and we use them in our investigation and other development. So actually here I'm not going into creating any new components or the new entities. Actually this is a simple thing. You can create a new component like this. And also you can create new entities by going to there. And the only thing I want to know you guys is when if we created the entity for first time, then we should grant it for IFS sys access, because you know MW's our middleware server is communicating with the database with IFS sys, and if you do not grant it with sys access, then you can end up with some issues. So actually this is a point actually we do not involve with. So here actually I'm going to import some components into my my project right now. In this situation, actually I have some training components. I use these training components in my training, and in other scenario, in the actual customer scenario, you can import the related customer components, and then you can import them into your project. So you know how we can get these components in the customer harvest. We can go to the customer harvest, and then you can copy these copy your required components into a folder, and then you can copy them. And then I will go into my project location. You can see that it is existing C projects or D test. You can see that inside this project files, there is a folder called workspace. Go into there. You can see that my previously created component is also available there. Then I will paste these components here. Then I will go back to the project and go to the components. Then I will refresh. Then you can see that these all three components are available in my project right now. So as a first example, here I'm going to create a simple Aurena page. You can see that my target is to create this page. Actually, you can see that it shows some country details here. And also this Aurena page, and you can see that it use list component here. Now the first thing is I want to create, because you know in countries page it use trn country entity. So first thing here I want to do here is create a OData endpoint for trn country entity. So if I go back to my project under trnent component, you can see that trn country entity is available here. So if you go to the database, you can see that these data are available for that TR.
I think there's a connection issue with Samira's. Let's wait a few minutes.
Hello, sorry guys, there was some network interruption. Then you can hear me right now. Can you hear me?
Yes, Samira,
Yes,
we can
Samira.
hear.
Okay, my screen again. Can you see my screen again also?
We can see some.
Yeah.
Okay. And actually, what's the last point you you could be heard in my before uh, I lost my connection, and I have described this thing. I think I will continue from this. So you have missed a part.
No, I think from that point onwards will be fine, Samira.
Okay, thank you, Jonathan. That our TRN country has these data, and we have the TRN country entity. So here what I'm going to do is uh, expose this TRN country entity as a OData endpoint. So for that, uh, I will create a new projection file. So you can create a projection file by going to your component RMB, and then in this list you can see that there is a projection UXS model. So I will use that. Then I can give a name here. I will get a name. It's okay. Then you can see that our projection file has been created there. You can see that this is the projection name, this is the component, and also so you can see that the layer is core. It means that our projections files are supported by the layered architecture. Then you can put some comment here. Likewise, we can give some description, and here categories users. Actually, this is the type of the endpoint we can expose expose. Actually, I will discuss this later in the session. And yeah, that is our projection file. And in the first, as the first thing, I will deploy this projection file without doing any change. You can use this generate code and deploy option here, or you can go to your client file, and also there is this option, and you can use any of that. Then I will generate code and deploy. Then you can see that as mentioned in previous session also, this .svc file has been deployed to the database. Also, you can see that other than that, there are a set of files are generated by the code generator. You can see that there are a set of files. If I see these files, first I go to the enterprise handling base projection file. Actually, it has this base part because it is a template based generated file. So I will go into there. You can see that at that moment there are nothing, any content in here, simply these details only. And if I go to the base.plsvc file, you can see that there are some default types and also some default these etag methods functions. Likewise, these are the stuff. And apart from that, there are, you can see that some files, some JSON files. Actually, the JSON files contains some metadata. You can see that this is a enterprise handling middle tier metadata JSON. This is middle tier doc metadata JSON, and this is a client metadata JSON for projection. Likewise, these files contain some metadata in JSON format. And if you see the enterprise handling.svc, this is the file which is deployed into the database once you deploy, once you generate code and deploy. So in that file, we can see there are some anonymous blocks. If we check the first block, you can see that it use a model design sys package. Actually, this package is introduced in app 10 for Arena, and in previous versions in app 9 or app 8, you couldn't see that package. Actually, this package is used to generate some metadata. In this scenario, you can see that it has created some server metadata. And now I think you have idea. It has generated this metadata, and this metadata is used in this client metadata for projection JSON file. And below that, you can see another anonymous block, and you can see that in this block, it creates some client metadata in JSON format. Likewise, this created JSON metadata should be included in this middle tier client, in client metadata, and this server metadata in this middle tier metadata. And there is also another one called for document metadata generated by this package, this block. So this is the content of the SVC file, and apart from that, there are some types and also some functions which are included in this base PLSVC file. So the here also you can see that actually this is the PLSVC file includes some base methods, and also there is another file called you can see that this enterprise PLSVC file. Actually we didn't create it right now, but there can be a file like that. So what happened when you generate code and deploy, it merge all the contents of base PLSVC file and all the from this enterprise handling.psvc file, and merge both into the enterprise handling.sac file, and then this has been deployed to the our database. If I explain it like that, if you see this trn country object, in PLSQL, actually we can see that trn country.base PLSQL file, and also we have the trn country.plsql file. Actually, we done our implementations and our new method or functions are created in this file. So when we generating the code and deploying the files in the database, this base PLSQL file, content of this base SQL file and content of this PLSQL file are merged into this API files, and this is the file which is deployed to the database. Likewise, in this scenario also, you can understand PLSVC, base PLSVC, and PLSVC file in here has been merged, and then deploy this enterprise handling into the database. So this is some insight about the generated code. Other than that, you can see that there's some CSV file, and actually this is used by the framework. This includes some data about the category, this category. So this is how we can explain these things about this projection file. Now we have deployed this file into the database. So now we can access this projection using our specific URL notation. So in IFS, we have a specific URL notation for accessing this projection file. I will show it now. So you can see that it uses our server name and the port, and after that main IFS application projection version 1, and then you can put your SVC file here. In my case, it's enterprise handling.sc. If I check this, then you can see that it has moved to our OpenID authentication. Then I will provide the credentials, and then you can see that here it shows a document. We call this as a service data document, service document. Actually, this service document is a high-level advertisement kind of thing. It shows the overview of the entity sets in this projection file, and at the moment it's empty because we didn't have create any entity set in our projection file. And actually, there is we can see a detailed view or the comprehensive detail regarding this projection. So for that, you can append $metadata here, and you can see an XML document which describes the contents of the enterprise handling SVC. Actually, at the moment, you can see that enterprise handling content is null because we didn't create any entities right now. So then I will quickly go back to my project, and then I will create a new entity set here. We'll use keyword entity set, and then I will provide the entity set name. This entity name should be always the plural name of our entity. So here we are going to expose our TR and country entity. We'll give it here. always actually this means this trn country entity set has set of trn country entity. If sometimes you may can see that other than this plural name, it has been used trn country set for that, because if trn countries is already used, then developers has been used trn country set for this entity set. So however, now you can see that our entity set is trn countries, and it exposes all the metadata and the data of this trn country entity. So this is our OData endpoint. So then I will generate code and deploy. Cannot recover trn country entity. So mistake, country, it should be country. You can see that this file has been deployed. Now if I see my generated codes, you can see that under projection, previous it was empty, but now it has added the TR country entity here. And also likewise in this PLS3C file also, you can see that it has added new types. And also you can see that it has added new CRUD methods here. Likewise, this CRUD create, CRUD update, likewise. Actually, what happened there is actually it creates some wrapper methods to invoke some functionalities in our web pages. So you can see that inside these wrapper methods, if I go to this CRUD create, you can see that using this wrapper method, it has been called to our base server API methods. So this is how this method has been generated. And if I go to the actually the time is now over, I will quickly show this thing. Now if I go to our projection, and I will load the service document, you can see now our TRN country entity has been added there. And if I check the metadata, you can see that in this XML document, our entity is there. And also it describes other related keys and types, like these all the data. This is why we call this as a comprehensive or detailed document. Likewise, this BESC option we use in Oracle or SQL. Likewise, this gives some detailed overview of our projection. So I think now we can end up the today's session. In today's session, I will go some quick recap on what we have done in the session. Actually, here what we have created some developer studio project and develop an entity set and a projection file, and now you know SCC file and the generated files. You have some insight about them, metadata creation, sales document, metadata XML, and actually we have to we did not use that or data keywords. And actually we have covered these 2 points, and we will cover rest of the things in Monday's session. Actually there are some few topics to discuss, and then we can wind up today's session. And I think you have some insight. Actually I have quickly go through this because since time permits. And Nalaka, is there anything to add?
Yeah, thank you, Samira. We'll continue the rest of the stuff in the day 2, which is Monday. Do you guys have any questions regarding the topics which I have discussed so far? Okay, let's wind up this session. Thank you, guys. Thank you for joining. Please join the second day as well.
Thank you.
Thank you all.
Thank you.
Thank you.
Bye.
Thank you.
Thank you.